x plus b, where b is a constant, real constant. Is it a subspace of V or not? Is it a subspace? Anybody? Is it a subspace? I have given already this question. Is it a subspace? In fact, is it closed with respect to addition? Suppose you take a polynomial, W is in f is in W, that polynomial should be of the form x plus b1 for some suitable real number, right? Similarly, you take any element which is in W, the polynomial should be of the form x plus b2 for some suitable b2, right? But you take the sum would be 2x plus b1 plus b2. B1 is a real number, b2 is a real number. This is a real number, okay, but the thing is, it is not of the form x plus real number. It is not of the form x plus some real number, right? It's looking like a 2x plus some real number. Therefore, in fact, it is not closed with respect to addition, vector addition, right? Is it right or not? So therefore, it's not closed means not a subspace. Is it closed with respect to scalar multiplication? Is it closed with respect to scalar multiplication? The answer no, right? If you take a equals to, yeah, no, sir. So a equals to 2 means, suppose you take an identity polynomial. It is in W, therefore it is some x plus some constant. But what about a into f of x? It's a into x, that means a equals to 2 into x. So the coefficient of x is actually 2 here. Therefore, it is not an element of W, right? So coefficient of x should be 1 plus some real constant. Here coefficient of x is 2. Therefore, it is not in the element of W. Therefore, it's not closed with respect to scalar multiplication, right? Suppose you take a polynomial of the form W is equals to set of all polynomials such that the polynomials of the form a into x square, where a is a real constant. Here my vector space is P2 over the mean space of all polynomials with the real coefficients with the degree at most 2. Question is it a subspace? Anybody? Is it subspace? Is it subspace? Yeah. Anybody?
Yes, sir.
That's right.
Yes, sir.
Yes. Right. You take a polynomial that is of the form a into x square. Similarly, you take another polynomial P2 that is in the form bx square for some suitable b1 comma b2 belongs to what about p1 plus p2? A plus b into x square. Therefore, the polynomial of the form a into x square, right? A into x square, right? So therefore, it should be in W. It should be in W. Therefore, it is closed with respect to addition. It is closed with respect to addition. Is it closed with respect to scalar multiplication? Is it closed with respect to scalar multiplication?
Yes,
Yeah.
sir.
Yes. Right. Suppose you take a real constant. Right. You take a polynomial of the form like this: a into x square for some suitable a. C into f is nothing but what? C into a of x square. Therefore, it is some real number into x square. Therefore, it is of the form. It is in the element of W. Therefore, it is closed with respect to scalar multiplication. Therefore, it is closed with respect to addition and scalar multiplication. Hence, in fact, it is non-empty. Okay, because 0 is an element in W. Why? 0 can be written as 0 into x square, right? Therefore, it is in the W. Therefore, W is non-empty, and it is closed with respect to addition. It is closed with respect to scalar multiplication. Hence, it is a vector space. It is a subspace. Suppose same question. If I change the argument, suppose you take like this: p of x is equals to a plus x square. Here is a real number. My vector space is P2 over R. Is it a subspace of V? Is it subspace?
No, sir.
No. So therefore, in fact, it's not closed with respect to addition. Therefore, same argument like this, example 1. Same argument like this, example 1. So it's not a subspace of V. Right? Suppose you take this example. Set of all polynomials of vector space V. So my vector space is actually take this, you take any polynomials like Pn of x or like P of x, P of R or Pn of R. You can use this notation, Pn of R or P of R. So set of all polynomials of a vector space V whose degree is like suppose you take 3, whose degree is 3. Is it a subspace of V? So for sake of our convenience, you need to take P of R. It's better. You take a P of R. P is equals to P of R. That means space of all degree polynomials. Okay. So is it it is always subset of V. Okay. Good thing is it a subspace of V? Is it subspace of V?
Sir, 0 will not be known, no, sir.
Yeah. So 0 is not there. Therefore, it's not a subspace. It's not a subspace. 0 is not there. In fact, it's not closed. In fact, yes or no? Suppose you take f of x is equals to x cube. Is it an element of W? Yes, because degree is 3. Suppose you take another polynomial minus x cube. What is the degree? Degree is 3. What about addition? 0. So therefore 0 polynomial would not have a degree 3. Therefore, it's not closed with respect to addition, right? So therefore it's not a subspace of V. Yes or no? Is it closed with respect to scalar multiplication?
Yes, sir.
Is it closed?
If scalar is 0, it is not.
Yeah, if you take a scalar as 0, it is not possible. Therefore, it does not belongs to W. It is not closed with respect to scalar multiplication. Thing is, what is the difference between this and this? Suppose if you take this polynomial, if you take this, suppose you take W is equals to set of all space of all polynomials of the form Px is equals to, suppose you take a into x cube, where a is a real number. What is the difference between this and this? What is the difference between this and this? Yeah, what is the difference between this and this?
Here is a 0. ఏ 0 తీసుకుంటే 0 పాలినామిల్ అవుతుంది సార్. ఇక్కడ 0 పాలినామిల్ ఉంటది.
యా, ఇక్కడ 0 ఉంటది, బట్ ఇక్కడ ఉన్నది డిగ్రీ 3 పాలినామిల్స్. ఓకే, బట్ ఇక్కడ మీకు యాక్చువల్గా ఏంది 0 కావచ్చు, 0 డిగ్రీ రైట్, 1 డిగ్రీ కావచ్చు, మీన్స్ 0 ఆర్ ఎట్ మోస్ట్ 3 డిగ్రీ ఉంటుంది. ఎట్ మోస్ట్ 3 కదా. ఇక్కడ మాత్రం పక్కా 3 డిగ్రీ ఉండాలి. ఇక్కడ మాత్రం డిగ్రీ 3 పాలినామిల్స్ మాత్రమే ఉంటాయి. ఇక్కడ ఏంటి 0 డిగ్రీ కూడా పాసిబుల్ ఉంటుంది. 0 డిగ్రీ పాసిబుల్ ఉంటుంది, 3rd డిగ్రీ పాసిబుల్ ఉంటుంది. 2nd డిగ్రీ పాసిబుల్ ఉంటుందా? ఉండదు. ఎస్ నో? సో 0 డిగ్రీ ఆర్ 3 డిగ్రీ అంతే కదా. సో ఇది 3 డిగ్రీ అన్నాడు కదా, ఇది 3 డిగ్రీ ఉంది కదా అని చెప్పేసి వెక్టర్ స్పేస్ సబ్ స్పేస్ అని రాశారు అనుకోండి, ఫినిష్. రైట్? ఇది క్లియర్? సో therefore it is a subspace, okay, but thing is it's not a subspace. This is not a subspace. Right? Suppose you take this, W is equals to space of all polynomials. My vector space is this. Suppose you take P of x is non-negative. Space of all polynomials in V such that it is non-negative. Yeah. Is it non-empty? In fact, is it non-empty?
Yes.
Yes, because 0 is a element which is in W. Because 0 of x is always 0. This is always non-negative for every x. 0 is there. Okay. Is it closed with respect to addition?
Yes, sir.
Yes, because you take an element, you take first element, you take second element which is in W. That means P1 of x is non-negative, P2 of x is non-negative. Sum of non-negative is always non-negative. So it is closed with respect to addition. It is closed with respect to addition. Is it closed with respect to scalar multiplication?
Yes, sir.
No, right? Suppose you take a equals to minus
Sir.
1.
Yes.
Yes. A equal to?
Minus 1. It's a real number. Right?
Yes.
Suppose you take Px is equals to x square. Px is
Yes.
equals to x square is always non-negative, right? For every x. Therefore, Px is in W. What about A into Px?
No,
Negative.
Minus x square. So coefficient is negative. Therefore, total minus x square is less than or equals to 0. Therefore, it is not in W. Therefore, it is not a subspace. Suppose it, so a problem with negative, right? Suppose I'm going to take this like this. Suppose you take this. Space of all polynomials. V is equals to like this. Over R. My Px is, my Px is like this. Px is less than or equals 0. Means non-positive. Right? Is it a vector space? Is it a subspace of V? Is it, first of all, is it non-empty?
Yes, sir.
0 is there. Okay, first is over. Next, is it closed with respect to addition?
No, sir.
Yes, right? Yes or no?
Yes.
Suppose
Sir.
B is less than or equals 0.
Minus-
P1, P2 in
minus-
W. That means P1 less than or equals to
multiplication.
P2 also less than or equals
Okay,
0.
okay, sir. Okay,
Sum
sir.
of negative is always non-negative. Sum of less than or equals 0, always less than or equals 0. Therefore, it is closed with respect to addition for every. Is it closed with respect to scalar multiplication? Anybody?
No, sir. If we take negative scalar,
Give
we'll
me,
get
give, yeah, you take, give me polynomial first. Minus
minus
x.
x cube.
Minus x square.
Minus
Right, it
2
is in-
for scalar.
Yeah, you take a equals to minus 2 or minus 1, enough. Right, A into F is equals to x square, which is non-negative, less than or equals 0. Therefore, A into F should not be double. Therefore, it's not closed with respect to, it's not closed with respect to scalar multiplication. Yeah, suppose it is 0. In fact, 0. Suppose this is 8. Suppose W is equals to space of all polynomials. Exact 0. 0 polynomial. Yeah, is it a vector space? Anybody?
Yes, sir.
Yes,
Yes.
why?
Yes, sir.
Hey, why? Why?
Take
Zero
any
is
two
trivial
polynomials,
subset.
0, 0.
Huh?
Zero is trivial subset.
Yeah, 0 space, singleton space, improper subspace. So it is always a subspace. See, what is a set here? You're taking that polynomial which is 0 polynomial, right? 0 polynomial is always a trivial vector space, means it's a subspace. Suppose I'm going to take a restriction. Suppose you take like this, space of all polynomials, which is positive. Is there a subspace?
Zero does not belong to.
Yeah. In fact, 0 does not belongs to there. Therefore, is it close with respect to? Yeah, 0 is not there. Okay, but is it non-empty or empty?
Non-empty, sir.
Non-empty. Suppose you take this x square plus 1 is always positive. Yes or no? Therefore, this p of x is always in W. Therefore, W is non-empty. Right? X square plus 1 is always positive because x square is non-negative, plus 1 is always positive. Therefore, px is in actually W. W is non-empty. Question is it closed with respect to addition? Yes. Closed with respect to addition. Same trick like this. Is it closed with respect to scalar multiplication?
No, sir.
No. Therefore, it's not a vector space. In fact, it does not contain 0 element. Therefore, it's not vector space.
Sir, one doubt, sir.
Yeah, tell me more.
Sir, one condition is W should not be empty. One more condition is 0 belongs to W, no, sir.
Both
Which
are same
one?
equivalent. Both are equivalent. Both are equal statements. Already I told you, right? Test 1, test 2. I'm stated, right? See, it is non-empty is enough, Amma. It is non-empty enough. Of course, 0 is element in W means what? W also non-empty, right?
Okay, sir. So sometimes if W is non-empty and 0 is not belonging, so it is okay, sir.
Sometimes.
W is non-empty, but 0 is not belonging. So it is okay, sir. If it is
No. Suppose you take this. Sometimes it is non-empty, but 0 does not belong to there. Yes or no? Your argument is that like that, right?
Yes, sir.
Is non-empty. 0 non-empty. 0 is there. 0 is there. Non-empty.
0 does not belong, sir, but it is non-empty, like 9 one.
Okay. Suppose you take this. W is equals to 1 minus 1. Your vector space is R or R. Tell me. Is it a vector space? 0 is not there now.
It is not closed, sir.
Yeah, that's what my point. First of all, is it non-empty? Yes. Is it closed? No. Right? It's non-empty, okay. It's non-empty, okay. But is it a vector space? Is it a subspace? Not, right? Because it's not closed. So thing is, both are equivalent arguments, but the thing is, non-empty is not same as saying that 0 is not same as saying that non-empty. But the thing is that when you take the statement whole, that are equivalent. Statement 1, statement 2 are equivalent. W is non-empty, that implies that W contains 0. W contains 0, that will imply that W is non-empty. W contains 0, W contains 0, W is non-empty, okay. But W is non-empty means that doesn't mean that W contains 0 vector. W లో 0 ఉంటే డెఫినెట్ గా నాన్-ఎంప్టీ అవుతుంది. there is no problem. బట్ థింగ్ నాన్-ఎంప్టీ అయినంత మాత్రాన 0 ఉంటుందని చెప్పలేము. ఇదే ఎగ్జాంపుల్. అర్థమైనా?
Yes, sir. Thank you.
Yeah. It's not. Yeah. Suppose you take this. I take this polynomials. P is equals to space of all polynomials.